Hello, welcome back to Learning with Ms. H. Today we're going to go through our Earth Science lesson on star groups. As always, you have a bell work assignment here that goes over previous information or connects it to the real world. And what we'd like you to do today is review how does the Earth move around the sun, what's it called, and then how does that movement affect us here on Earth? What does it do? What does it cause? You are going to do a lesson on star groups, and then when you're finished, if you have time, you should go ahead and take a look at the astronomy project for the next lesson and see if you can get a jump start on it. So for now, go ahead and grab your materials if you haven't already. Get started on the bell work while you pause me, and then come back to join us for notes. Welcome back. We're going to talk about star groups today. You've already learned about one of these. If you remember yesterday's lesson, we talked about galaxies. A galaxy is a group of stars. It literally has star group in its definition. Group of stars, gases, and dust held together by gravity. Literally has star group in its definition. So that's the first type. There are two other types we're going to talk about: binary star systems and star clusters. We're going to learn what a binary star system is, and you need to know the names of the three types of star systems. You don't need to know the details about them. It should be fairly easy to recall and remember some of these, but you don't need to worry about being able to explain these on the test. You just need to know the names. There's two types of star clusters, and we are going to talk about those. Remember, as always, if I go too fast, pause the video on the slide you're on, finish up, and then restart the video to catch up with us. Binary star systems. This is more than one star that is gravitationally bound to each other. So if you have two stars gravitationally bound and orbiting each other, that is a binary star system. There's three types that you hopefully wrote down on the last slide: visual, eclipsing, and spectroscopic. About half of our stars in the universe are actually in binary systems. So, definition of binary star system: stars that are gravitationally bound and orbit each other. That gravitationally bound and orbiting each other are the keys there. You're going to have a center mass in the middle here where this plus is that they're going around, and they actually appear to go around each other as well as they go around that central mass. So what is not a binary system? If you have two stars that are in our line of sight that appear close together, that is not a binary system unless they orbit each other and are gravitationally bound. An example of this is our star A and B right here. A is further away, B is closer. If you look, they're both in our line of sight here. So what we see is B right next to A, even though what's actually going on is you have multiple light years of distance between them. So they are not gravitationally bound. They're too far away. And they're not orbiting each other that we can see. So because of that, they are not a binary system. It has to have both of those characteristics in order to be a binary system. So the first type we mentioned was visual. Visual means you can see it. So we can watch the two stars go around each other. Sirius is a great example of this. You can watch the two stars as they go around each other in the night sky. So this is images taken over time of the movement of Sirius A and Sirius B. We're not going to worry about writing all of this down. You just need to know that visual binary is one of the types, and it's something we can see. The next one is an eclipsing binary. This one we can't see the actual movement, but we can see the effects of it. So we see the amount of light or the apparent brightness of the star system, and it changes as the position of the stars change in relation to each other. So it's going to increase or decrease brightness depending on where the stars are located. So the second type, eclipsing binary, and we can see the brightness of the star, but not the movement itself. Spectroscopic is our third and final type of binary system we're going to talk about. We can't see the star's movement, we can't see the changes in light, but we can see the changes in the electromagnetic spectrum. So if it's approaching us or moving away, we'll see it shift from red to blue. The next type of star grouping we're going to talk about is a star cluster. These star clusters are groups of stars that are gravitationally bound to each other, so they stay in their vicinity, in their little clique together, but they don't revolve around each other. So you don't have them orbiting each other. They just kind of stay gathered together like a group. These star clusters are going to have a larger density of stars than any other area of space. So they are very clearly going to have lots and lots of stars in one location. Our two types are going to be globular and open. So a globular cluster is very organized. It's almost spherical in shape. It can be anywhere from 10 to 30 light years across, and it's generally older stars that are going to appear yellow or red. They're further along in their life cycle. They're not quite as hot. So this right here is a globular cluster. You can see it's got a fairly circular form to it here. Open clusters are going to be much younger stars. They're going to be a little bit larger in size. They have a lot of open space in between here. Lots of dust and gas in here. These stars are still getting born. They're younger stars. They haven't quite used up all of the stuff around them, so there's still more stars forming. So much younger. They're blue in color because they're much hotter. And there's only a few hundred stars here versus the hundreds of thousands, hundreds of millions of stars that are in the globular. And you can very clearly see the difference here when you compare the two. The open can be really any shape, and there's lots of space in between them. The globular is very tightly clustered together here. So that is it for our star clusters notes for today. We're going to go ahead and move on. Those are our real star groups. We're going to talk about some fictional star groups, some imaginary star groups, if you will. And those are constellations. Constellations are not actual real groups of stars. It is groups that were made up by people as we think we recognize shapes in the sky. It's a way for us to kind of map out the sky, and it was a way to navigate before all of modern technology came about. So, for thousands of years, humans have been grouping together stars in patterns that they think they recognize in the sky. There's lots of different patterns that are out there that people recognize and see and have named, but there are 88 official constellations that are recognized by the International Astronomical Union. That's the official worldwide large main group for astronomers. It is also the group that came up with the definition of a planet that killed Pluto and made it a dwarf planet instead of an actual planet. So, when you're looking at a constellation, the stars are going to be different distances from us and from each other. Looking at their brightness, you can tell a little bit how far away they are, but remember that it's also a function of distance and luminosity. So it's not an exact, it's just a best guess. But you're seeing a two-dimensional object. So when you look at Ursa Major, Big Dipper, you see this two-dimensional object that looks like this. And what's actually being viewed is all of these stars at varying distances away. They're usually named from Greek or Latin mythology because the names came about thousands of years ago, and that's where the majority of the world population was at the time. And you kind of have to think of space as a giant sphere around us in order to understand the night sky. And we'll see an image of that on the next slide. So here's what I'm talking about when I say a sphere around us. If you put the Earth in the center and you make basically a ball around us, so we're the core, and then you have this ball shape around us, that's where all the stars are, is in this, filling up all this space around us. So here's a 3D image of the night sky. We would be down here in the middle of it. And you can look out in all directions and see different stars from different viewpoints around the globe. Stars are always going to be in the same place in the sky. They do appear to look like they're moving to us, but it's because we are spinning on our axis and then revolving around the sun. It is our movement that causes the, quote, change in the star location. They're always in the same spot. An exception to this is Polaris. That's our North Star. It is directly above us to the north, and because it is immediately above us, none of our movement actually affects the location of that. It is always due north no matter where we are in our rotation or revolution. It's the star that was used for navigation for centuries before modern technology. Explorers could look for the North Star and know that if they head towards it, they're going north. If they have it to their back and they're walking away, they're going south. And then they could keep it to their right or left to move east or west. So how does this work? Answer these questions in your notebook really quickly before we move on. Jot down why stars move, why you think constellations are visible in the southern hemisphere and not the northern hemisphere, and then do you think those also move? So take a minute, pause the video, answer those questions, and then move on with notes. All right, so movement of constellations. Again, we see constellations in different seasons because of where we're at in our revolution around the sun and our rotation on our axis. Basically, it doesn't have anything to do with the tilt of the Earth and what season it is. It has everything to do with where the sun is in relation to us. So if you draw out the orbit of the Earth around the sun, you'll see that we can't see through the sun. So anything that's on the opposite side of the sun is not visible to us. We can only see what's on our side of the sun. So as we rotate on our axis, we can see the stars on one side and the sun on the other. And then as we revolve around the sun, we see a different section of sky as we move around. So it's our moving around the sun that allows us to see those different constellations. Those constellations are always in the same place, and they're always visible there. It just depends on whether they're blocked from our view or not. So as we move around the sun, we get a different view of the sky. Exceptions to this, we talked about the North Star. You also have the Big and Little Dipper. Those are very far to the north. They actually point to or include the North Star, and they are visible pretty much all year round because they just rotate around the North Star. So they are always visible. And again, they help us find the North Star by recognizing these star groups. So if you go up from the tip of the Big Dipper, you'll see it meet up with the end of the tail of the Little Dipper, and that star that's right there is Polaris. So, because of our rotation and our location in space, we have the changing night skies. Constellations that are in the southern hemisphere's night sky are different than those in the north. Take a second, think about why that might be. Pause the video while you consider that and jot down an answer. We'll talk about it on the next slide. And then go ahead and take a look at this time-lapse video, watching the Milky Way move across the sky over time. You'll see some meteors going across and those kinds of things. It's kind of a cool time-lapse video of the movement of the night sky. Once you're done, go ahead and come back and restart the video. Okay, so the reason that we see different constellations in the north than we do in the south is because we have different views of the sky. So if we're up here in the north, our view is to the north of us and a little bit to each side. But down here in the southern hemisphere, their view is to the south of the planet and to either side. So we see a different set of constellations than they do. And it's a different set year round. We never switch ends. We don't like flip upside down. So in the northern hemisphere, we're never going to see the same constellations that they see in the south. One of the other good things about constellations is they're used to help create star maps. So if you can recognize constellations in the night sky, you can tell what time of year it is, whether you're in the northern or southern hemisphere, and you can create a map to help navigate by. So this is our last slide for the day. I'm going to go ahead and go through the homework with you. Star groups and constellations. I'm going to open that in a new tab here for us. It is one of these not really a quiz assignments. You can take it as many times as you need to get 100%. It is multiple choice, multiple select. There's some fill in the blank down here and true false. On these fill in the blanks, please make sure you follow directions. Spelling counts. If you spell it wrong, it will get counted wrong. So please make sure you look it up if you're not sure how to spell it. And then for question 10 down here, use the number keys to type in the number of constellations. So you're going to actually type a number. So if you put FOUR instead of 4, it will count it wrong. If you put TWO instead of 2, it will count it wrong. So please follow directions when you get to these fill in the blank questions wherever they are at in your questions, because I think it may be on randomized question order. So when you get to those, make sure you are following directions, paying attention, and doing it how it asks you to. It will tell you the right answers when you're done. So if you get them wrong, jot down the right answers, figure out why you missed it, and then go back and take it again so you can get 100%. That is it for today's lesson, but you will need to work on your astronomy project tomorrow. So if you have time at the end, you can go ahead and click the astronomy project here and look at what is going to be required of it. You're going to have two options. Both of them are going to involve some type of video presentation. My students in class with me are going to have an option of standing in front of the class and presenting or uploading their video. You guys are just going to need to upload a video. And it does actually need to be a video upload. So if you do option 1, you'll upload a video of your constellation project. If you do option 2, you're going to actually do the regular upload Google assignments, and you will include your video in your presentation. And I will tell you more on that in tomorrow's video. For now, choose which one you want to do, and know that you will have to do some type of video for each. So you can research a constellation of your choice, find this information, create a model, and then videotape yourself explaining the model and telling us your facts that you found out. Or you can do the universe project. You can use the pre-made Google slide presentation and research the information from that, and then basically record yourself going over a couple of the slides. Include that as one of the slides in your presentation. Submit that. You're going to have 9 days from today to work on this. It'll be due on October 15th. So October 15th by 11:59 is the due date. So you have 9 days to work on this. Plenty of time to get this done as long as you start it the day it's assigned, which is officially tomorrow, but you can get a jump start today if you'd like. That's it for today. I will catch you next time.